Okay, so today we're going to talk about the ideal gas law, and the ideal gas law is the equation PV is equal to nRT. Okay, so we've seen all of these letters before. So we know that P is going to be for pressure. Now there's actually different values you can use for this. They'll require different constants, but we're going to stick with atmospheres. V is volume. Now in our other gas laws it didn't matter if it was in liters or not, but you'll notice from our constant here it is in liters, so that is going to require you to switch that. Remember that's 3 spots to move the decimal if needed, since 1,000 is 10 to the third. N is your number of moles. R is the ideal gas constant, and there's different values based on what you're going to be using in, and our value we're going to stick with most of the time is 0.0821. You might see 0.08206, that's fine to use too, but usually we'll stick with the one that's a little simpler on that. And then T is obviously temperature, and it does need to be in Kelvin, and remember our number for Kelvin is 273. Okay, so you're always going to know R. It's a constant, and it's not going to change. And so since it's 5 variables total, you know 4, you're going to be given 3 of the variables, and you're going to solve for the 4th. Again, make sure everything's in the correct units, otherwise your answer won't come out correctly. There is another value you can use for R when it's in kPa. And if you do that one, in kPa it would be 8.314, but you'll be given that if we do want you to do a different problem. Or you could always convert and get it to atmospheres using our standards. Okay, so here's a problem. We know that there are 3.0 moles of gas. It's heated to 300 Kelvin. The volume is 2.0, and we want to know at what pressure is the gas. So that means we don't know P. We do know V, and it's already in liters, so that's good. N is our number of moles, so that's 3.0. R we know is 0.0821. And T is already in Kelvin. It's 300. So we're going to plug this in. Now you've got 2 options. Some people would like to rearrange and solve for V. If you want to do that, that's fine. Or I'm sorry, for P. Other people are just going to plug it in and solve. That's what I usually do. So we don't know P. V is 2.0. N is 3.0. R is 0.0821. And T here is 300. So we need to get P by itself. Now if anybody did rearrange and wanted to find what P was, P would be equal to nRT over V. So if you wanted to rearrange that first and plug in, that would be your other option. So we're going to plug in our numbers. We're going to take 3.0, multiply it by 0.0821, and times 300. Now keep going on this. If you're going to multiply that side out and write it down, that's fine. Just write down every number in your calculator. Then we're going to divide it by 2.0. Okay, so we get a really long number on here, 36.945 ATM. ATM is usually measured to the 10th on here. They did only give us 2 sig figs, and sometimes they're only going to give you 1 sig fig, like only say 2 liters. So in here I would either take 36.9 ATM, or I'd be fine if you round it to 37.8 ATM. Either one's okay here. Okay, so here's the problem where we're looking for grams. So we've given you a hint here. We're going to find moles, because we know we can always go from grams to moles using the molar mass. So we're going to plug in what we know here, and we're going to solve for N, but then there'll be an extra step at the end. So for our pressure, it's 1. Volume is 2.5. N on here we don't know. R we always know, 0.0821. And our temperature, double check that it's Kelvin, it is. So let's plug that in. 1 times 2.5 is equal to N times 0.0821 times 298. Okay, so we're going to plug these in and solve for n. Again, if anybody wanted to, n would be equal to PB over RT if you prefer to do it that way. So do the side that doesn't have a variable first. So 1 times 2.5 is just going to be 2.5. We're going to divide it by 0.0821. We're also going to divide it by 298. Again, wait till round on the end here. Okay, so I'm going to go ahead and just do this to my normal 2 decimal places. Probably should have given you more detail on the atmospheres and said like 1.0. But this is 0.10 moles. But we're not finished yet because this wants us to go to grams on here. So we know that this is carbon dioxide, and carbon dioxide, when I add up C and 2 O's, is 44.01 grams in 1 mole. Again, proportions or the factory label here are fine. Okay, so then we'll multiply this, and our answer would be 4.4 grams. Okay, they give you the opposite, give you grams first, just do molar mass and get it into moles, then go ahead and plug it in the equation. Okay, so again, you always know R, you know 3 of the variables. They might tell you some things at STP, and you know the B and the T that way would be the only reason to be a little bit different.